Yes, I really was impressed by both talk. And one of the points that I think was raised initially by Silvestro, and I would like to have his opinion on, is the possibility to transition from to the stimulation of sensory cortex to provide sensation, and the kind of difficulty. There's some that are known. There is this work, ancient work of Benjamin Libet, where there are very strange latency effect that one can observe in sensory cortex, and I don't know what kind of perspective you see there.
Yeah, thanks a lot. I mean, the very first difference, I think it's really related to the kind of disability you want to address. So in general, I mean, even if you talk with Andy Schwartz, Andy would tell you that in the future, even amputees should have everything implanted in the cortex. I'm not sure ethically it is that true, but that's one issue. Going to patients who really need a cortical implant, so quadriplegics, the main issue there are two main issues. One, in general, every time, as for Todd Kuiken for the TMR, you are stimulating and recording close by, then it's very complicated. I mean, I talk with Andy's people and Sliman Besmaya, closing the loop, stimulating and recording so close, it's very complicated. So there is a technological, if you want, issue. The other issue is really that there are many different problems when you try to replicate the simple approach we used for the periphery. One is what you mentioned. In general, the other thing is that you get a large variability in the response. You need to be extremely selective, because if you try to have, let's say, a recruitment curve in terms of increasing the relationship between the stimulation frequency or amplitude and the response you get, you need to be extremely selective, otherwise there are different neurons responding and then the sensation is blurred, it's not anymore that sharp. So in general, what I do believe, and I know the results they are getting in Pittsburgh, you can get touch information. So you can have the possibility to provide the information, I'm touching one finger or another one in different locations. That's something probably you can do, which would be already something interesting. But the more you try to restore sophisticated things, texture recognition, or even modulation of grasping force, the more even physiologically it could be complicated. So one other possibility then would be to investigate other ways for stimulating. So to go, for example, for optogenetics or these kind of things. But then this makes even less translationable in the short term, the result. So I know that they are working on this, but I'm not really fully convinced that they could restore sophisticated information in closed loop.
Thanks, Silvestro and Sandro. Someone else has questions? Otherwise, I actually have a more general question that, so I was inspired by first of all, by the talk of Sandro, actually, by the discussion we had yesterday with Lina, and then I see like a path in the talk of Silvestro and of Gregoire, which is the importance of the sensory system. I mean, here, clearly, both of you, you're actually stimulating the sensory system. And the thing is that it works because Dennis was so quick in learning everything, and the rats and monkeys and hopefully people are actually walking by engaging the sensory system instead of the motor system. So my general question is, I mean, there's so much hype now going on in the sensory system, sensory cortex stimulation and all that. So is neuroprosthetics going sensory? And if yes, why?
In general, I would say yes. If you think about cochlear implants, for example, is the main success in terms of neurotechnologies. One of the main issues is that first, stimulation is easier than recording. And second, stimulation of the sensory system, it's in general often simpler. But this is not always the case. Think about visual prosthesis. In that sense, it is probably, I don't want to say untouchable with the current solution because friends of mine will kill me, but let's say it's very challenging. So in general, yes, now the application for the intrinsic limitation of the technology we are using are more sensory. But when the technology is not enough, like for visual restoration, then even sensory it's not feasible. So the issue is we work with the technology we have, and the technology we have now, it's limited, and then often you can only do sensory.
So let me start more philosophically. I think one of the greatest mistakes of motor neuroscience over the past 30 years is to have forgotten the sensory system, especially when it comes down to locomotion, right? I mean, 30 years of work on central pattern generator have completely deviated neuroscientists from the real question, which is sensory motor control. You know, and I think it really, of course, there are central pattern generator in the spinal cord, and there are circuits that can oscillate, just like circuits oscillate in the brain to process sensory information and create consciousness. But I think this is not the main feature of this network. This network, they are meant to process sensory information, make sense out of it in order to activate the motor system. And I think strongly encourage, the young scientists in the room to refocus on the interaction between the sensory system and the motor system to really understand the way we control movement. And then by extension, response more to your question, is prosthetics going sensory? I think no, what it needs to go is sensory motor, because we know that when we close the loop, this is when we start creating prosthetic systems that are actually functional. Why? Because they're ecological. Because you respect the natural operation of the central nervous system, which is to link perception and action. I mean, we knew that 100 years ago, and we've forgotten this essential concept, that have been developed by the German philosopher. So remember, when you want to work in prosthetics, the sensory and the motor component are so intimately interlinked that you have to link them together.
Thanks, G. I completely agree on this. And Elvira?
But about this sensory, just to bring back what we were discussing before about robotic rehabilitation, so do you think this is a problem actually in robotics? Because it's maybe difficult to give sensory feedback with this robotic device.
So Elvira, this is exactly the same concept, well, because there are central pattern generator in the spinal cord, let's move the leg to activate central pattern generator and a miracle is going to happen. Well forgotten the key concept that sensory inputs are activating this circuit in the spinal cord. So no, if you remove weight bearing, you're not going to activate this circuit. That's what the exoskeleton are doing. If you generate information below the foot during swing, you do exactly the contrary that the central nervous system is expecting. So you are actually disrupting the way the motor circuit should be activated. So the way exoskeleton have been conceived back in the time, was just not respecting physiology, in particular with the focus on the sensory system. This is why, the system as Robert Triner presented, which is like assist as needed, like soft, really enhancing basically the sensory information, the desired movement, rather than inducing the movement is the key to way to go in the future.
Let me just add that more or less what we are trying to say and what the people working, like for example here, Cosemi Jan on brain-enhanced neurorehabilitation are trying to do is to restore all the different parts of the sensory motor coordination. So you have BCI for controlling, but then you need to have also the way to restore as much as possible the sensory feedback in the appropriate way. Because if you are not using the brain in the right way, or you are not providing the sensory information in the right way, then the rehabilitation cannot be effective.
Marco?
So actually, I wanted to propose a switched question with respect to the talks to each one, but Marco anticipated the question about the sensory part, but I still think there is another aspect that could be interesting. So the switch question for Gregoire is, Silvestro, working on the sensory stimulation of the peripheral nerve, what kind of information can you inject in the brain by stimulation of the spinal cord? And the switch question for Silvestro is, Gregoire talked about electrical stimulation of the spinal cord for locomotion. is there an advantage in using peripheral nerve stimulation in locomotion specifically, like with respect to only stimulation?
I mean, I start since I have the mic with me. We are, as you know, we are trying to combine spinal cord and peripheral stimulation for locomotion. Let's say for grasping and reaching, I think it's clear that there is an advantage in combining because of the richness of the local information, or closer to the action I was trying to say. So you can do something that probably at the spinal cord level for grasping you cannot do. But even for locomotion, you could add something specific for specific actions. Because one of the reasons why what we do all together for locomotion works so nicely is that it's also a repetitive movement, which makes this kind of control easier because you can exploit all the neural structures. For any reason, if for any reason you have to do something not repetitive, even locomotion becomes, if you want, closer to reaching and grasping than we believe. Many years ago, I read a paper on experimental brain research saying walking is more tapping. So, I mean, in general, when it is repetitive and simple, yes. But when it is a bit less repetitive and unexpected, then you need to go also peripheral, because the muscular selectivity you can achieve at the spinal cord level, even in this case, also in this case, it's not enough.
I mean, I do not like to think that we stimulate the sensory system. I want to believe that you activate, the sensory feedback circuits. This means the sensory motor circuits. For me, it's a loop. They are the building block of motor control. It's the simplest element that are linked together and that enable the activation of the motor system. So I think if we start thinking that we just activate the sensory system, then we're going to make a fundamental mistake, like people who focus only on the motor circuit made before, right? We really need to reconcile both and see it as a unified system. This is the key.
So yeah, great work, definitely, without any doubt.
Thank you.
So I'm wondering a bit more, like for the spinal cord, I think it's walking and using the arm is kind of a clear target. So the question is a little bit if you think about stroke patients. So gait is not the biggest problem in stroke, so it's more hand function and it's more distal hand function. And for the more, let's say, severely stroke patients, they cannot open their hand because they have not enough extensor forces, there is spasticity. And with all what we do, like cortical brain stimulation, training, it's very hard to address these patients. So do you see a potential, although for sure the spinal interaction for grasping, etc., it's much more complicated than for gait, do you see a chance of, with these nice tools you have at hand, to address also unilaterally the spinal cord, combine it eventually also with signals from the brain or with peripheral stimulation? I mean, it's quite complicated challenge, but these patients, for these, we don't have very good options at hand at the moment.
So, thank you for this question, actually. So, I think we have developed all the concept and technology, that enable us to address maybe other type of first function, upper limb, and also pathology, potentially. And we have been very lucky also that Eric Rouillet in Fribourg, is opening his laboratory in primate with a lot of experience on the upper limb, actually. And Marco is a recipient of a very nice fellowship, actually, to exactly study this problematic with Eric Rouillet in Fribourg. So it's really exciting. We are going to take all the concept, the neural interface, the brain-spinal interface, and all the modeling to the upper limb to try to address this question. With the problem that so far what we observe is that the cervical spinal cord is designed in a way that we don't have specific access to extensor of the digits. So we'll see, we'll have to develop some clever way to be more specific as we have been able to do for the lower limb.
Spasticity is a big problem.
Or you can make peripheral implants. I'm the peripheral guy, so I tend to remind people that, what you can do implanting in the spinal cord, you can maybe also easily do peripherally. My 2 cents, or the combination, of course.
Well, I think we can discuss a lot. Unfortunately, now we have to close the panel. I really would like to thank Sylvester and Gregorio because their talks were really fantastic, and and it's a small Chinese store, and inspiring, I think. So congratulations. I really hope that both of you can achieve the clinical translation and actually help people in their life. Okay, so now there's the lunch, and at 2 we come back here. Thank you very much.
Thanks.